Hello, I am Preetam Biswas. I have completed the task 6 of the GRIP internship by the Sparks Foundation. It is the prediction using decision tree algorithm. The purpose of the task here is that if we feed any data to this classifier, it would be able to predict the right class accordingly. And here our dataset is the IRIS dataset. So firstly, I've imported the required libraries, which are namely pandas, numpy, simborn, and matplotlib. Then I'm reading in the dataset, the iris dataset, and these are the first 5 and the last 5 rows of the data set. Then these are some insights of the data, having 150 observations and 6 features, in which 4 are of independent type and 1 feature, that is this species, is dependent on the target variable, and ID is just the serial number. Next, these are some statistical properties of the data with mean, standard deviation, percentiles, minimum and maximum value. Then we visualize our data using a strip plot. And we can observe that each class of species of flowers here, which are Setosa, versicolor and virginica, having more or less equal number of data points. So our dataset is said to be a balanced dataset. Next, we move on to continue our visualization for the 4 independent features using distribution plots. And this first plot is for sepal length. This is for sepal width, which is a typical normal distribution. This plot is for petal length and this for petal width. Next, I've done a heat map to analyze the relationship between the variables, and here are the correlations given. So we can have a quick view about that. And also, in addition to this, I plotted some joint plots with the individual distribution on the same plot in the site. So firstly, I've considered sepal length and sepal width, and it looks like this, the visualization, where we can see a negative correlation. Next, I took sepal length and petal length like this, and we notice that the dark spots here are referred to as more dense points. Then the sepal length and petal width using hexagon plot. Here again, the darker the hexagon is, the higher the concentration. Then the petal length and petal width, and we can notice that positive correlation exists here. Then the petal length and sepal width, it shows a negative correlation. And lastly, the petal width and sepal width, and it looks like this, negative correlation. Next, I've done a rack plot to visualize the data more precisely. So it is only for the sepal width versus sepal length, and it shows that this is the rack within which the data points are lying. Then I have done a pair plot, and it comes out like this. Now by looking at the result of this pair plot, we see that all the blue points in each plot are well separated from the orange and the green points. So from this legend, blue is Setosa, orange is versicolor, and green is virginica. So it is clear that the cluster of species versicolor and virginica are closely related, whereas Setosa is more distinct. And in addition to this, if we observe more precisely, then we can see that versicolor and virginica are partially overlapping in each plot. So that means there are some feature combinations which have very less overlapping between these, and hence these features are very important for our classification task purpose. Next, some feature engineering is done with the data. I have created two new variables and attached them with the existing dataset by simply taking the differences between them. Like this sepal diff is created by taking the difference between sepal length and sepal width. Then I've created four more new variables and attached them to the dataset. And I've created those variables but just by shuffling them and taking the differences. Next, again a pair plot using the new variables is done, and it comes out like this. And here again we can see that Iris setosa is well separated from the other two species of the flowers, but has some overlap between versicolor and virginica. The legends are same here too. Next, I am building the classification model. Firstly, I've dropped the ID variable, which is just the serial number of our observations. Next, I've imported the libraries for training the dataset and more specifically decision tree classifier for this task. Next, separating the independent and the dependent variables. Then I'm training the data with test size 0.2, which is 20% of the observation, and splitting them into validation sets. Then I am plotting a decision tree using the decision tree classifier. And it comes out like this. Here we can have a look of the Gini coefficients with the corresponding samples and the value. Next I am feeding a sample data and trying to see whether it is giving me the right class or not. And as expected, it has come out to be the Iris virginica. Lastly, the visualization of the decision tree. Since our data is already trained, now we just perform a cross validation by using the accuracy method, and it comes out to be 93.5% accuracy. And also the validation test accuracy comes out to be 83.3%. Next, the accuracy test on the unseen test data, and it comes out to be 90%. Lastly, we move on to plotting our decision tree, and it comes out like this. Here we can see the corresponding values and the class. So if we put the values of the four columns, then we get the right class along with the Gini coefficient. So this is our decision tree classifier. Thank you.